Hello, everyone. Obviously, I am not here today, so I am recording this video on Thursday afternoon so that you don't miss the lesson today despite me not being here. So we are doing lesson 16 today of Unit 2, and this lesson is just basically more practice with the elimination method that we've done the last 2 days. So I'm going to go through all the examples here. You can either watch it on the big screen here in the classroom, or if you would prefer to watch it on your own on your computer, that's fine. Either way, you have access to this video that is linked in the slideshow. So you can go back and watch this at any time. Like I said, we're going to do some more practice with elimination, and then you're going to do some practice on the cool down for this lesson. So let's take a look at this first set of examples today. We have a system of equations right here that has been solved for x and y, and it's been solved using the elimination method, and we're going to go back and we're going to see if we can figure out what happened in each step. So let's take a look at step number 1. So if we look here, we have 4/5 x plus 6y equals 15, and negative x plus 18y equals 11. And as you can see, if we look at step 1, clearly the second equation stays the same. Second equation stays the same, which means the first equation is changing. There's something going on in the first equation. So let's see what they multiplied by here. So 4/5 x became 4x, 6y became 30y, and 15 became 75. Okay, so it looks like what they did was they multiplied the first equation by 5, because 6y times 5 is 30 and 15 times 5 is 35. If we weren't sure, let's check on Desmos to make sure that we're correct. So we'll check on Desmos to make sure the calculations are right. So is 4/5 times 5 equal to 4? Well, let's check here. So 4/5 times 5 is indeed equal to 4. All right, and then we know that 6 times 5 is 30, and 15 times 5 is 35. So pretty clearly the step here, what the person did was multiply the first equation by 5. So multiply the first equation by 5. Okay. To get 4x plus 30y equals 75. So now let's look at step 2. So step 2, it looks like the first one stays the same and the second one changes. Okay, so the first one stays at 4x plus 30y equals 75, but the second one changes. So it looks like if I look at negative x becomes negative 4x, 18y becomes 72y, and 11 becomes 44. So it looks like they multiplied the second equation by 4. Negative 1x times 4 is negative 4x. 18y times 4 is 72y. And 11 times 4 is 44. So now that was the second step, was multiply the second equation by 4. Okay, step 3. Let's see, x went away. It looks like they added the two equations. 4x plus 4x is 0. 30y plus 72y is 102y. And 75 plus 44 is 119. So step 3 was to add both equations together. Okay, so that was step 3. Step 4, they got y equals 119 divided by 102, which is 7/6. So step 4, they divided both sides by 102. So that was step 4. Divide both sides by 102. Okay. And they got y equals 7/6. Y equals 7/6. Okay. And then let's see here. We go to 4x plus 35 equals 75. So it looks like they're dealing with this first equation up here, and it looks like they plugged in the 30y became 35. So it looks like they plugged in 7/6. So let's check and make sure. All right, let me switch to a different color here, but let's check to make sure that 30 times y, 30 times 7/6 is 35. So let's double check that. 30 times 7/6 is indeed 35. So that's what it looks like they did in the next step, is they plugged in 7/6 for y in the first equation. So they took the first equation and they plugged in. So plug in 7/6 for y. Plug in 7/6 for y. All right, in the first equation. Okay, so they plug in 7/6 for y in the first equation. And then they go from here to here. So 4x equals 40. All right, it's pretty obvious they subtracted 35 from both sides. So subtract 35 from both sides. And then step 7, they finished it off by dividing both sides by 4. So divide both sides by 4. So they took an equation and they actually multiplied both equations by something. They multiplied the first equation by 5 and they multiplied the second equation by 4, and that made it an easier system to solve. And that is essentially what our goal is for today, is to use multiplication to allow us to either add or subtract the two equations together. So I'm going to take a look at the second set of examples. So we're going to do these two, and again, we're going to do them without graphing. So let's take a look at number 1 here. When I look at number 1, I can't add them together. If I add them together, I'm going to get 5x plus 3y equals 1 plus 9 is 10. So that doesn't help us because neither variable is eliminated. So we can't do that. And let's try subtracting them. Right? If we subtract them, if I try subtracting them, 4x minus 1x is 3x. Okay, 1y minus 2y is negative 1y, and 1 minus 9 is negative 8. So that doesn't help us either. which means we're going to need to multiply one or both the equations by a number in order to create a situation where we can add or subtract the two equations. So you'll notice I can either, there's two things I can do. I can either look at the x's, in other words, multiply the bottom equation by 4 to get a 4x, or I can multiply the top equation by 2 in order to get 2y and 2y. It doesn't matter which one you choose. I'm going to choose to multiply the first equation by 2. If I multiply the first equation by 2, I end up with, 4x times 2. 4x times 2 is 8x. 1y times 2 is 2y, and 1 times 2 is 2. So if I multiply the first one by 2 and then keep the second one the same, okay, I keep the second one the same, that allows me to subtract the two equations. If I subtract the two equations, the y ends up getting eliminated. 2y minus 2y is 0. Okay? So 8, so let's subtract everything else. So 8x minus 1x is 7x, and 2 minus 9 is negative 7. So when I subtract those equations, I get 7x equals negative 7. Okay? So I can finish this off by dividing both sides by 7. And x equals negative 7 divided by 7 is negative 1. So x equals negative 1. All right, now I'm going to plug back into either of the two original equations because I found x. Now I have to find y. So I'm going to pick whichever one looks easier. All right, in this case, it really doesn't matter which one we pick. So I'm going to pick the first one here. So I'm going to take the first one, 4x plus y equals 1. And I'm going to substitute or plug in negative 1 for x. Okay? Well, 4 times negative 1 is negative 4, and I'm just going to drop everything else down. So negative 4 plus y equals 1. Okay? And I can finish this off, all right, by asking myself negative 4 plus what number is 1? That's going to be 5. Or if I can't do that, I can add 4 to both sides and get y equals 5. So x equals negative 1 and y equals 5. Okay. Let's take a look at the second example here. And let me clear out my whiteboard here to allow me to do the second one. So again, the second one, I can't add or subtract the two equations. If I add them, neither variable goes away. If I subtract them, neither variable goes away, which means that now I need to do a multiplication. Okay, there isn't a single number I can multiply 8 by to get 12, but I could multiply the top equation by 5. If I multiply the top equation by 5, what happens? I end up with 8x times 5. So that's going to be 40x. Okay? 8 times 5 is 40. 1y times 5 is going to be 5y. And 11 times 5 is going to be 55. So that becomes 40x plus 5y equals 55. And if I keep the second equation the same, so 12x plus 5y equals negative 15, we can see if I subtract 5y minus 5y is 0, the y ends up disappearing. So that is what I'm going to do, is I'm now going to subtract both equations. Okay? So 40y minus 12y, 40x, minus 12x. Okay, that's going to be 28x. And then be careful here. This creates a double negative. This is not 55 minus 15. It's 55 minus negative 15. If you don't know how to do that, use a calculator. All right, 55 minus negative 15 is not 40, it's actually 70. All right, a double negative makes a positive, which makes it like adding. So 55 minus negative 15 is 70. And then I can solve this by dividing both sides by 28. So 70 divided by 28, 70 divided by 28 is 2.5. So x equals 2.5. Okay. Again, now I'm going to go back and choose one of the two original equations to find y. So I'm going to choose the first one again. So 8x plus y equals 11. And I'm going to plug in 2.5. Going to plug in 2.5 for x. So 8 times 2.5. Okay. 8 times 2.5, and we can use a calculator again if we don't know how to do it. So 8 times 2.5 is 20. Okay, so this is going to be 20 plus y equals 11. And I can finish this off by subtracting 20 from both sides. So y equals 11 minus 20 is negative 9. So y equals negative 9. X equals 2.5, and y equals negative 9. So again, our goal for today is to simply do some more practice with solving these systems by elimination without graphing, where we have to multiply one or both the equations by a number in order to create a situation where we can either add or subtract the equations. So you're going to do something similar on your cool down. So what I would do if you've written this down is to have this up as you're working on your cool down. Your cool down is in the slideshow for today.